Hello and thank you for joining us on this edition of NASENI Milestones. This is the place where we provide you with information on the multifaceted science and engineering infrastructure programs and activities of the National Agency for Science and Engineering Infrastructure, NASENI. Today on the program, we will visit the Engineering Materials Development Institute, MD, Akure, established to provide engineering and capacity building services in materials testing and characterization, manufacturing and designing of machines, foundry services, furnace manufacturing, and production of assorted types of machine parts. There is a whole lot of science and engineering works taking place at MD Akure. And on this edition of NASENI Milestones, we shall be examining the design, modeling, and the simulation unit, the manufacturing, as well as the foundry units. And other aspects of MD's exploits, which we may not be able to bring you today, will be brought to you in our subsequent editions. Welcome to the program. I am Kirian Umayo. Today, we'll start with the design, modeling, and simulation unit of the Manufacturing Services Department. MD personnel in this unit design machine concepts as the first step in the modern-day manufacturing process. Let's now join Engineer Eke Ogunkoya, head of the unit.
What we do here basically is to design, to model, and simulate components and machine. In fact, the product development of EMBI starts with the design here. We do design conceptualization. From this conceptualization, we do design consideration. And when we are okay with a chosen design, then we start our modeling. As you can see here, we have our flagship product, which is 100 kg rotary furnace. This is the full assembly of the product. We didn't just arrive there. We have the sub-assembly. This is the sub-assembly of the barrel. We have the conical section. That's the barrel now, making which is a part, and this is the conical section, which is also a part of that sub-assembly. This is another flange making up that sub-assembly. We have the tank sub-assembly. We also have the exhaust sub-assembly, which all make up the final rotary furnace which we have here. This is the drawing. We developed the drawing here, which fits our manufacturing unit or foundry unit, depending on the product that we want to get. We deploy high-powered computers here. We use we use software such as Pro-E, Autodesk Inventor. We use AutoCAD, and we also use Granta for material selection. We don't just design and take to them. We dictate to them which material to use. Of course, in collaboration with the other unit, the manufacturing unit and the foundry unit, we sit down together based on the facilities we have, availability of materials. Then we choose the right material which is suitable for each of the machine. So this is the working drawing that serves as an input to our manufacturing units. This is our product here, the working drawing that we have done. This is our 100 kg rotary furnace. You still see it when you get to foundry. It's in operation. It's our flagship product. I told you earlier that we do simulation. Simulation entails subjecting the machine to real life situation virtually, such that if there's going to be any failure, we would have rectified from this. So this is our 300 kg rotary furnace going through simulation process. All the moving parts are moving. You might not be able to see very well, but if you zoom, you can see the gear moving, the barrel is moving. So we are subjecting it to real life situation is going to encounter in service life. So if there's going to be a failure here, we go back to drawing board, we reprocess, and we come out with a better design. We have a frictionless grinder. It's one of the reverse engineering works we embark upon. This is it as bought. We did the modeling. After the modeling, we disassemble. Those are the assemblies that made up the model. This is a sub-assembly now of the model. That's the stance of assembly. Then we have different parts. After going through all of that, we sit down and analyze. We do part by part comparison. This products. Is the material available in our market? If it's available, then we go with that choice of material. If it's not, we change. At times we do a little bit of modification to suit the resources available to us. Our 5 kilowatt smart turbine. This is also a reverse engineering work. That's the full assembly of the model we are having here. That's it as bought. So breaking it down now, we take them part by part. That's another part, your sub-assembly you are seeing. That's the propeller sub-assembly. Okay? This is a diffuser. It has 3 of these, all of them arranged together to form the turbine. By embarking on this kind of project, we've been able to domesticate the technology, number one, and of course we are intervening in rural electrification because we have so many rural environments around us with streams. Once they have stream, we install this for them and they have electricity.
Engineering Materials Development Institute, Akure, is equipped with the requisite machinery for the manufacturing of different types of machine parts, equipment, fabrication and welding of parts to form the designed concept. Engineer Abimbola Idewu, head of the manufacturing unit, takes us to the workshop where machining, fabrication and welding take place.
Basically, what we do here is to produce machines and equipment in line with the detailed design drawing. The concept of the machine that we want to produce, the drawing of the unit parts will be produced and given to us. We will machine and fabricate the unit parts one by one. Then we will now assemble them together. After that, we will paint for aesthetics and for prevention of corrosion. This unit is divided into 2 basic sections, which are the machining section and the fabrication and welding section. Here we have the 1.5 meter lathe that we can use for various machining operations like boring, facing, turning, and so on. The operation that is going on here is the production of shaft for the shell stand of the 100 kg rotary furnace, and this shaft is being machined in line with the detailed design drawing. Here we have the turning operation of tensile samples that can be mounted on the Instron universal testing machine. From there, the mechanical properties of this material can be determined. Here we are machining aluminum alloy, and this is the detailed design drawing that we are following in order to produce the standard tensile sample. The VMC 1010H is a vertical machining center that can be used for various milling operations. It is a kind of machine wherein all you need to do is to input your program using the interface here, and in line with the program that you have input here, the machine will perform the operation in line with what you have programmed there. Now this machine has some advantages over the conventional machines in the sense that parts can be produced faster on this machine when compared to the conventional machine. Then you can produce millions of parts and they will have the same dimensions throughout. In line with the detailed design drawing, we cut, fabricate and weld the parts together in this section. In order to cut here, we have the guillotine shear that can be used to cut mild steel plate, stainless plate, or any other metallic plate that is not more than 3 mm thickness. After cutting, if welding is needed to be done on the plate that you have cut, we'll now move it to the welding section where we'll do the cutting. Now, the essence and the usefulness of that operation is to cut those plates for the production of fuel tanks. Here we can see molding boxes, we can see the ladu. All these are unit parts of the 100 kg rotary furnace that have been welded together. Here, the operation that is going on here is the welding of the shank or the carrier for the ladu of the rotary furnace. So here we have the electric arc welding operation going there. Here you can see that we have our MIG machine that can be used for MIG welding operation. When I say MIG, I mean metal inert gas welding operation. Now, the MIG can be used for welding stainless materials. And this is an area that we have an edge in our fabrication and welding operation. Within this unit, another machine that I want to introduce to us is the laser cutting machine. The laser cutting machine can be used to cut our metallic plates more accurately than the oxyacetylene cutting or welding operations. You know, the oxyacetylene welding equipment can be used for welding and for cutting. But on this machine, a better finishing is obtained when we use this machine to cut metallic parts. The essence of this operation, this fabrication and welding operation, is that we've been able to use it to produce some of our machines and equipment that are being manufactured here. One of such is the frictionless grinder, and this is the frame of the frictionless grinder. You know, the production of the frictionless grinder is in progress. So we've been able to put this is the hopper and this is the frame of the frictionless grinder. We have a project that has to do with the reverse engineering of a 5 kilowatt smart hydro turbine, and as you can see, these are some of the parts that we've been able to produce, using the TIG and MIG welding operations. This is another unit part of the 5 kilowatt smart hydro turbine, which we are trying to carry out the reverse engineering of it.
Next, we go to the foundry unit, a part of the production process. The process starts from design, where the idea of what to be produced is made and passed on to the foundry unit. The design could be engine spare parts made of cast iron, following the foundry process.
The one I have with me here is a drawing of the brake shoe. The brake shoe, which serves as a brake pad for train. After the drawing is being generated, it is carefully studied, and then we now come here to the pattern making workshop, where we translate this drawing into a pattern that can be used to produce mold, inside which multimeter is going to be poured. In this unit here, we make our pattern out of wood, out of metal, out of plastic or composite, depending on the quantity and then the quality expected from such casting.
To make a pattern using wood, the cross-cutting machine is used. It can cut the wood at an angle or straight. In a situation where the wood requires to be increased in size, the thickness machine serves that purpose. The machine also laminates the wood. The next step is to plane the wood to ensure you have a smooth surface that will be easy to work on. And to incorporate curves on the wood, the fan saw machine is used to create the curves. All manner of curves desired on the pattern can be achieved using the machine. Molding is a very important aspect of foundry work. It is a process by which the pattern of what is intended to be produced is used to make mold.
It's a pattern for a pump part which was produced some time ago for National Water Resources at Kaduna. If a casting requires hole inside, there is what we call core box that goes with the pattern. Where the core is going to be fixed is already incorporated on the pattern, which is referred to as print. This is the casting itself, and that is what this pattern is meant to produce when it is in production. We have other patterns there. The drawings are here too. This is another one. This is impeller. This is impeller. The pattern is here. I will show you the casting when we get to the workshop. You can see this is also a core print, up and down. This is a new product of EMDI. We call it circular manhole cover. Circular manhole cover. These are used to cover some electrical or wire installations on the road. This is what we call bull gear, pattern for bull gear. You'll be surprised that there is no gear here. There is no gear here, but this is what you actually need to be able to assemble the cores inside. This is what forms the teeth of the gear when it is molded and the cores are assembled around it.
In the course of NASENI Milestones series, we will bring you another program on Engineering Materials Development Institute, Akure, and we shall be taking you on the sophisticated laboratory of the institute, as well as the manufacturing of furnaces and their application in steel melting as part of foundry services rendered by the institute. It is very clear and understandable that Nigeria may be lagging behind in science and technology development compared to the Western world, perhaps due to poor funding and neglect by the successive administrations, plus inadequate policies to drive the sector. But the nation is blessed with high-profile and competent professionals in the various fields of science and technology development. This is because there are scientific and technological breakthroughs, as can be attested to by the ingenuity of professionals at the Engineering Materials Development Institute, MD, Akure, where there are sufficient infrastructure and manpower to deliver capital goods and services through the application of science and technology, especially now that government is paying attention to science and technology. We hope to experience a situation where SMEs can adopt research results and products from NASENI in order to expand their business horizons through commercialization. Now, let's hear from the man who changed the course of history of NASENI and the chief executive of the agency, Engineer Professor Mohammed Sani Haruna, the executive vice chairman of NASENI.
Engineering Material Development Institute, EMDI Akure, is one of NASENI's specialized institutions that is designed to look at materials research, materials development, including composite and synthetic materials that we need for our fabrication, machine development, even scientific research. All the equipment NASENI use that we produce locally, we need an institution that will develop materials and material characteristics and pictures that will give us standard materials appropriate for this, including metallic, ceramic, plastic, and composite materials, including synthetics and even alloys of materials. So Engineering Material Development Institute have been doing this very well and has advanced in such a way that it is from there, due to lack of performance of steel industries and even aluminum factories, we invented and innovated our own furnaces, from rotary furnace to even induction furnace, where we recycle scrapped irons, scrapped metals in order to produce ductile iron. In fact, we mix with other metallic components to give us certain features, ductility of iron, elasticity, corrosion-free, in short, alloys of different materials. These are the things we use to develop workpiece we need to produce our spare parts, to produce the machines we are fabricating from different institutes. We also have succeeded in using our center in Akure in the production of small hydro turbines. All the 3 turbines we produce, the actual materials, the metallic and plastic component are produced from Akure through recycling of scrap, through our own invented rotary furnace. Of course, if the steel factories are performing, we don't need to produce furnace to produce workpiece for ourselves. All we need to do is to order the steel or materials, or give them specification from this steel manufacturing outfit to meet our demand. So the success of our reverse engineering of cross-flow turbine, the one we learned from Indonesia, has led to the accreditation of the Institute a center of excellence in the manufacturing of small hydro turbine in Africa by UNIDO, and it has provided training for different men and women from other African countries, supported of course also by African Union. At different times we carried out training for the Africans.
Here is the Managing Director of Engineering Materials Development Institute, Akure, Dr. Samuel Olubenga.
Our own business is to intervene in the area of materials, science, and engineering into the economy of the country. We do this through research on various kinds of materials in whatever form they exist. These materials could be metals, ceramics, polymer, wood, and a combination of these materials. And we can modify them and also work on their application. We can further also develop products using these materials for engineering application. In the past, we had challenges of fund, but with Mr. President Muhammad Buhari, that is gradually getting to be a thing of the past. He has graciously placed EMDI, NASENI, in the right path by putting us directly under the presidency and also following what the Act says to fund NASENI properly. And I'm sure with this, the dividends of such funding will be seen by the citizens and by everybody in the country, and we'll be able to appreciate what NASENI is really made to achieve in our economy.
And that's our package for today, and I hope to see you again on NASENI Milestones. I am Kirian Umayo. Bye for now.